Good afternoon, everyone. Thank you all for joining today's Resideo webinar session. We are excited to be providing an overview of our Resideo hydronic products today, and included in our session, we're going to review several of our newer water products that we launched earlier in 2021 as well. My name is Jamie Quanrud, and I'm part of the Resideo Academy team. And on behalf of all of us, I'd like to welcome you to our training session today. Information on our webinar sessions are posted at our website at resideo.com/webinars. We are working on posting our webinars for the fall season coming on this website. So you can find information on upcoming webinars by searching under the discipline tab and looking at either plumbing or HVAC on the left-hand side of that search bar. And then you can also find recorded sessions on this same website by selecting on demand on the right-hand side of these filters as well. And then for our contractors who are joining us for today's live session, and you are interested in earning one NATE continuing education credit, there are just a few things to note. If you provided your NATE ID on your registration form, we will submit those details to NATE for your attendance of today's live session, and we don't need any additional information from you at this time. If you did not provide us with your NATE ID on the registration form for today's webinar, and you'd like to receive credit for attending our live session, we do ask that you email your first name, your last name, your NATE ID, and the date of the session that you attended to homes.university@resideo.com within 1 week from today. And we do submit this information to NATE 1 week following the close of each live session. Any requests that are sent outside of 1 week from each live session cannot be processed. And then as a reminder, we are only able to process requests for NATE credits when you attend the live webinar session, and we are unable to process requests for watching a recorded version of our sessions. If you'd like more information on the NATE program, please visit their website at www.natex.org. And then a quick note before we begin our technical overview. All of our attendees are muted. However, if at any point during our technical presentation you'd like to ask a question, make sure to use that Q&A feature that's found in your Zoom webinar controls. As always, we are reserving the last few minutes of our time together today to answer any questions that you may have as we progress through our technical overview today. So make sure to ask that question in that Q&A feature so that we can address it at the end of today's session. We're going to turn over the presentation to Mike Ortiz, who is part of our water sales team. He's going to be sharing his hydronics knowledge with all of us today. So Mike, we're going to turn things over to you.
Good afternoon and welcome everybody. Today we want to talk about our hydronics offering on the water side. We've expanded this considerably over the last couple of years, and we feel like we have a really good package now to completely turnkey a mechanical room. So shy of the primary equipment that's in the whether it be a boiler or heat pump or other type of heating device, we can pretty much take care of everything around the boiler as far as the near piping requirements go. So we'll touch base on, as Jamie said, on what our existing offering is, as well as our expanded offering now. So we're pretty excited about that. So we start off with, the core of every system, air elimination and water control. There's three main components here that we deal with, and I'm sure you're all familiar with it, as over the years we've offered them in different variations as far as the air elimination goes, and as far as the expansion tanks and boiler and backflow devices. These are the kind of the lifeblood and heart of how we bring water and fluids into the system. And so consistently we've tried to keep up with the technologies that are available and make them available to you guys as part of a package. So we start off with our backflow and fill valve offerings. We've got two different ones. We've got an FM911, which is a combination unit that has a backflow and a dial set to it. And we've also got our NK300, which is kind of our best offering. It's a cartridge fully serviceable unit. It is all combined into one package, and it's provides a lot of serviceability and testing that we don't typically see offered out there in the market on these units. So we'll go into a little bit more detail on that as well. Our base offering, is our FM911. It consists of our FVO6 100 dial set and our B900 backflow preventer. And the nice thing about this unit is it's kind of a set it and forget it dial type unit where you set the pressure on top of it, open it up, and let it do its thing to maintain the system. It also gives the ability to do a fast fill feature, which you dial up the pressure up a little bit higher and open it up, and you can actually regulate the pressure up and down as needed whenever you're doing your purging. The BP900 allows us to have a double check, so we don't risk contaminating any of the potable water in the house. If either one of the backflows in it or check valves in it get fouled, you're going to get some weeping out the vent, and that's an indicator that there's something going on in it and it needs to be serviced. So it's very important to pay attention whenever those things are showing signs, so that we can go forward and provide a nice safe environment into the home that we're providing the heat to. Something to keep in mind with this, it comes with both sweat and threaded connections in the same box, so there's no reason to dual inventory on your trucks. And so it also involves, like I said, a complete package offering whenever you're doing one of these jobs. The NKS 300 is available in press, sweat, and IPS. And the nice thing about this unit is it is a fully testable unit. It now comes with a 1/2-inch FIP vent port on it. And so it allows it to, again, be put in place wherever you're used to having a traditional backflow and fill valve. But it also allows you to be able to test those ports if you have a municipality that requires that. And so, again, full serviceability, 2 sets of cartridges in it, and one on the backflow side and one on the regulator side. It's fully isolatable, and it comes with a gauge, so you can automatically see what pressure you're set at. Something to kind of keep in mind, as things have changed and things have progressed in the backflow side, we now have these listed out in the UPC code as well as the IPC. And so if you have a municipality or an authority that'll come to you and sit there and say, hey, I need seal lifting, you can now look in section 603, 312 and table 603 for the BP900. The NK300S, has recently been also listed under UPC under 603 and also in IPC, now under 608, 17, 14, and .1 on the table. So again, they are recognized devices now. I mean, I think they were a little foreign over the years, and people would run into these things and say, what the heck is this? And, but now we're getting more and more local authorities and code officials that are accepting these and understanding what their application is. So as we pressurize these systems, and with these devices, as far as the fill valves go, what we're trying to accomplish is overcoming whatever static pressure we need in the system to be able to maintain constant pressure. And so if we take, pretty much a standard house and look at what we need to have, to the highest point or the furthest point in that system, we can do a quick calculation based on the type of head pressure we're looking at and the rise of the building. So if we look at 1 PSI for every 2.31 foot ahead, and we've got a situation where, we're dealing with basically 27 to 28 feet of rise on the system, we want to make sure that we can keep a constant fill in the system. So we take that 2.31 times that rise, and that gives us our 12 PSI, if we take it that way. If we look at it from the other perspective, where we've got 12 PSI in the system, times our 2.31, again, we come up with that 27.7 to keep constant pressure in the system. And then because it is a closed loop system, we don't have to worry about compensating for that in our pumping and displacing as we're doing circulation. So there are situations where we may have a higher building or a higher rise that we need to deal with. And again, the same things apply there. You know, if we've got a fan coil unit up in an attic and now suddenly we're dealing with maybe, you know, closer to 35 feet, you know, that system's going to get set at 15 PSI. You know, so it's important to have that understanding of that static pressure on the system and how we keep that constant. And, you know, that's a function of a couple of different things that we'll talk about a little bit later as far as the expansion tank and how that comes into play. You know, and speaking of which, you know, as I said, you know, we have three main components that we deal with when we're trying to control the pressure and air in the system. And one of the biggest pieces on that is the expansion tank. You know, typically these things come in pre-charged at 12 PSI. And so, you know, based on that last slide, we can take care of about 30 foot of head against that. That static pressure is also, you know, going to provide us a constant in the system so that when we're doing our pumping, we can now have a base to work against and maintain the system. You know, typically these tanks, you want to check them when they come in, whether you buy them from a wholesaler or it's something you keep on your truck before you put them on the system. You know, they have a little Schrader valve on the bottom of them. You can put a gauge on them, a low pressure gauge on them, see where you're sitting at. If you need to trim them up a little bit because, you know, in shipping, if they change elevation or stuff, sometimes we will see some fluctuation there, but most of the time they're going to be typically real close to where they were shipped from the factory at. We've got 100 PSI max pressure on them, 240-degree max operating temperature. You know, they've got a Butyl PDM diaphragm in them that again has been designed to take those temperatures and maintain a pretty good life on them. We offer a 7-year warranty on the tanks that we provide in both our packages and sell individually. So you can kind of keep that in the back of your mind as well when you're purchasing them. So as I said, you know, most boilers are going to come with a 30 PSI relief valve on them, typically on a residential application. And so because water doesn't compress, we got to have a place to offset that water as we heat it and cool it. And so that's the function of the bladder inside of the expansion tank. And you can typically look at accommodating any of that expansion through application of the right size expansion tank. And so that's why it becomes critical to understand what we're doing when we're putting in these tanks and how they're going to operate and what type of system it's going to be. So a lot of that's based on the system volume. You know, are we doing radiant? Are we doing radiators? You know, is it a baseboard system? I mean, so understanding those key components when we're sizing this is also another critical factor. Another piece on controlling the pressure is, you know, as I said, you know, we start off with a 12 PSI system and that's our static pressure. Well, if we determine that through pumping with the friction losses we have to deal with piping and fittings and everything else, that we need another 14 PSI in our pump to be able to go out and maintain the system, you know, we got to make sure that differential is going to come from somewhere. And so where we place this pump, it's critical that it sits at the point of no pressure change. And what we mean by that is, you know, a lot of you have heard the term pumping away, and that's typically pumping away from the expansion tank. And so if we don't properly do that and we pump into that expansion tank, what happens is that the differential that the pump creates is going to go into that diaphragm. It's going to be absorbed. And so suddenly, instead of having our 12 PSI, we end up with a negative PSI on the other side of that tank. And so instead of adding those two together, where it's the 12 PSI here, 14 PSI differential, and ending up with a 26 PSI that we actually need for the system, we end up cutting ourselves short, creating a lot of short cycling, drawing air into the system through the air vent, and creating a lot of different problems that need to be corrected just by placing that pump in the right area. So make sure that, you know, when you're doing these systems, that you're aware of what that where that pump placement is, how it's going to interact with the expansion tank, as well as that point of no pressure change, and keep you from having you know, issues with gaseous cavitation in the pumps, just meaning that we draw air into those pumps, those little air bubbles get against the impellers, they implode, and there's a tremendous amount of energy there. So we'll end up with a lot of damage on pumps just because of that pump placement and the fact that we start to cavitate some of these things. And that's just one of the, you know, many ways that that can happen. So again, keep that in mind when we're doing this, doing that placement. So I talked a little bit earlier about sizing and selection. You know, we offer a lot of different tables and a lot of different methodologies for doing this. There's a lot of rule of thumbs out there, you know, that people will use whenever they're putting in expansion tanks. You know, for years I've done this for this, and you know, that's just the way I work it. But you know, the best way and the best practice is typically to understand the volume of your total system. You know, how many gallons are in the boiler volume? How many gallons are in the mechanical room piping? You know, my supply and return tubing going out to a radiant. How many feet of radiant do I have? You know, and the two tables that we provide you here kind of give you those volumes. You know, so typically, you know, if you have a half-inch tubing and it's half-inch packs out there, you know, you take that times your footage. You know, you could end up as, you know, for 3,000 feet of pipe, you may end up with close to 30 gallons of fluid. Now we take the mechanical room and we start looking at 1.25-inch pipe or 1-inch pipe and ending up with 20 or, you know, 20 or 30 feet of piping, and there are more, you know, we may end up with another 5 or 6 gallons of volume. And then you move on to the boiler volume. You know, we're now dealing with a lot of boilers that are not high mass boilers. They have very little water in them, you know, a couple of gallons. But you start adding up all that volume, and then you start talking about, you know, maybe pushing up closer to 30, 35 gallons, and come over and look at what temperature am I going to run this system at? Am I going to run around 140, 130? Well, you know, based on that 40 to 44 gallons, you know, if we're at 130 degrees, you know, the TK15 is going to take care of what we're looking at as far as volume. Now, again, you know, there's all those other caveats that come into play and those variables. And something to always keep in mind, if I'm sizing a tank at the top end, or I'm sizing a pump at the top end of its performance, I always risk the issues with, you know, it operating at the top of its parameters. And that's usually not the best practice. So keep in mind when you're doing that, you know, if suddenly, you know, something goes on and we're now running at 150 degrees because maybe we needed to turn it up because we had an air handler or something like that, that 40 gallons is now, you know, marginal as far as being able to be used on that 15. So if we have a 30 in there, you know, we've got plenty of capacity, even at the lower temperatures, to be able to be safe within that system operating parameters. And so, you know, again, you know, sometimes the best practice is looking at the middle of the operating, whether it's be a system curve on a pump or the ability to size one of these tanks and make sure it's doing what we need it to do in the system. Now we go in, we say that, and then we provide you with the good old rule of thumbs that are out there. You know, if you look on this bottom chart with the nominal PEX tubing size, and you look and see, I mean, you know, it'll show 5,000 feet typical using a TK15. Again, you know, this is a rule of thumb. This is something that, you know, within the parameters and operating at the top of the scale, yeah, this may well provide you what you need. But again, you know, you need to size that system. You need to take the time to understand what we're looking at there, and make sure that, you know, in a pinch, this is what these tables are designed for. They're not going to get you in a whole lot of trouble because, you know, there's been a lot of parameters that have been factored into them. Up here with the different sizes of BTUs and boilers, which I think a lot of us are used to doing over the years, where we take in the rule of thumb is, you know, I've got a 100,000 BTU boiler, that's a 30-gallon tank, you know. depending on what kind of tubing or what kind of convectors I'm using or what kind of baseboard or radiators, there's going to be some variation there. And, again, the factor is volume. If we look at cast iron radiators or we look at baseboard, we're going to use a little bit more volume in those to transmit heat. So that's why your volume will change, and the rule of thumb is going to tell you to move up as far as the size and volume of expansion tank you need. The next piece is our air eliminator. These are two things everybody's familiar with. Our air scoops or air purgers, that the cast iron ones that have been on every boiler since the beginning of time. They did their job. They took care of getting air out when we needed it. With a proper purging, it made it very possible to have these run for years without any issues, maybe having to change the little air vent on top because it would clog up or get fouled up somehow. But then again, the new technologies came in. The SuperVents or micro bubble eliminators that have come out over the years, have gotten better and better as they've moved forward, and they provide a whole nother level of air protection that I think you can't get out of an air scoop, and I'll kind of show you why here in a bit. One of the core things with air elimination is purging. I mean, everybody I'm sure on this call has purged the system one way or another over the years, and the biggest thing is making sure that you're set up to properly isolate each zone and properly isolate the boiler from what you're trying to purge, and be able to get all the air that you can out of the system. There's nothing worse than having a trapped air bubble in a radiant panel that you can't get to and you just can't get flow out of it. And it, a lot of times comes right down to not having a proper purge on the system. When things accumulate and form those air blocks, like we said, you can't compress water, but you sure can compress air. And believe me, it will give you fits on any given day if you don't get those gases out of there with a good purge. Where the sources of air come from? Again, water coming in from a city main is full of air and oxygen. That's just by its nature and by how water works, that's what you're going to get. Again, improper, ineffective purging. One of the other things that have come up over the years is we've all learned, you've got to have an oxygen barrier on your tubing. If you don't, it basically breathes. And as it breathes and brings oxygen in the system, that's where we bring in these components that allow corrosion and allow the sludges to form and allow, we've got a lot of different things that go on in the system, from iron to copper to everything, brass, fluxes, cutting oils when they machine things. And if we don't properly take care of that water, we're going to just accelerate the downfall of our system. So it's critical to make sure we get those sources of air out of there, as well as make sure that we get rid of whatever initial air comes into the system and let the system operate as optimally as it can. We talked a little bit about air elimination with an air purger, and these are great devices. I mean, they're tried and proven. They've got an 1/8 inch connection on the top and a 1/2 inch connection on the bottom for an expansion tank. We offer them in 1 inch through 1.5 inches. And again, they're a thick, nice, solid piece of cast iron. They've got baffles in them that as the air comes through them, that baffle and the oversized cavity here allows those bubbles to permeate out and actually float up to the air vent and make their way out through the float. And as this cycles more and more times, we get more and more air out of it, whatever residual air is in the system. Now, something to keep in mind is we want to run these at about 4 feet per second for optimum operation. We want to get as much straight pipe on both sides of this thing as possible so that we take and make sure that we get as much air out of the system as possible through this unit. Again, that this is our media for relieving that airflow, is those baffles in there. So, the more times it can make a pass, the better off it's going to be to do what you need it to do as far as eliminating error. So as we've had the improvements in the technology, we've also had the improvements in this error elimination. I mean, you see these in a lot of different configurations. Our micro bubbler has a bronze body. It's got an adjustable air vent, so you can point it wherever you need it to go. We've got a stainless steel concentrator inside of it. The brush inside of it helps scrub the bubbles and the micro bubbles as they slow down and go through it, and get out very efficiently as much air as possible on each pass. It's critical to take the time, to service these if you need to, but they're pretty much trouble free. Once they go in, as long as we've got good water, we're going to have a good success with these taking out the air as they run their course. We offer these in a 3/4 through 2 inch, both in sweat and FYP sizes. We have recently, at the beginning of this year, started to offer a 1 inch and an 1.25 inch with Pro Press connections, kind of rounding out the whole package as far as our press offering goes. So, again, it's a good way to buy yourself some insurance on making sure that the air is out of your system and constantly going to stay out of your system. We offer a lot of variations on air vents, from the little FV1 heaven cold tops that you might put on top of an air scoop or on top of an high vent, to some of the more industrial grade vents that we offer that have built-in shutoffs, to our SuperVent. Our SuperVent is basically the top of our micro bubbler. And again, this is a really efficient vent. It's serviceable. We offer it in 3/8 and 1/2 inch. And again, it just kind of rounds out our offering as far as air vents go, if you need them in different parts of your system, to be able to make sure that you don't trap air up in a high point or a different part of the building. So as we talked about the 3 main components, we make a kit. And we make a lot of different variations of this kit now to really make you efficient on your trucks, and from a stocking aspect at your distributors. This kit allows you to have the ability to have some different options with it. We do it with both the NK300, and we do it also with the FM911. So we did kind of look at that as a better best. We offer it with the 30-gallon expansion tank, size 30 expansion tank. We offer it in 1 inch or 1.25 inch in all 3 connections now. So you can get a fully pressable kit that you can take out as a service or as a replacement package. It comes with also a service tank check valve as well. So again, it's pretty nice and convenient package to be able to put on your truck and go out and service just about any system. So the last piece that I'll talk about on the air elimination is kind of take us into another one of our new offerings, which is a hydraulic separator. When we talk about hydraulic separation or decoupling the system, we're talking about giving the boiler the ability to have the flow it needs to run at its optimal efficiency, to make sure it has the correct flow to run while it's condensing and not get drawn off to a point where, if we've got a larger flow consideration on the secondary side or the system house side, we're able to do that. Now, in the past, we've always used closely spaced tees and called it primary, secondary. And, by principle, this is what, we're doing even with a hydraulic separator. But in the case of, closely spaced tees, there was always a lot of considerations about whether or not it was being done properly. So when we look at the flow of how that loop runs, there's some considerations when we're doing the closely spaced tees. Do we have a minimum of 8 pipe diameters from the first elbow to the first tee? So 1 inch pipe, do we have our 8 inches there? When we talk about the discharge side of it, do we have a minimum of 4 inches or 4 pipe diameters between the secondary tee and the first elbow? Our closely spaced tees, are they a maximum of 4 inches if it's 1-inch pipe or not to exceed 12 inches. All those considerations have to be put out there and implemented whenever we're using those closely spaced tees. And as long as you follow those, these work great for doing what we're trying to do, which is decouple our primary and our secondary. Now, when we start talking about using hydraulic separators, there's a couple of more benefits to this that it now allows us to take advantage of using this type of device. The biggest thing is that, just like with the air scoop, because we're going to add a larger volume chamber here, we're going to take basically our flow of 4 feet per second and allow it to have a moment in time here where it actually drops it almost 9 times. So to about a 1/2 foot per second. Well, by doing that, that now allows us to do some air separation very efficiently, and also some debris and magnetic separation in an environment where it can now be serviced, as well as take advantage of the fact that we're no longer needing closely spaced tees, but now also getting the benefit of decoupling our system with a device that is designed to do that. Our primary offering is on the residential side, is we are offering a union model. In this union model, we're offering it 1 inch, 1.25 inch, 1.5 and 2 inch. Now, what's a little bit different is that instead of having to stock a specific fitting assembly with a body, we're offering the fittings separately. So they come in packs of 2. It allows you to, if you've got a situation where maybe on one side of it, you're going to sweat or press, and then maybe on the other side of it, you want to do IPS, that now gives you the ability to do that, because you can just buy the adapters you need and pair them up with the body you need. So it makes it real simple for, like I said, for stocking, and it also makes it very convenient so that, even your wholesale doesn't have to have a huge inventory of very specific lined out units. One of the biggest things we're offering standardly is magnetic separation in here. We use an aluminum nickel cobalt magnet, which is an industrial magnet. It's used in a lot of higher operating temperatures, and and it's less susceptible to corroding in environments that typically you might see other devices be impacted and start seeing some corrosion there. The biggest thing to keep in mind with this is that it gives you the flexibility to provide a service point on your system, and that service point makes it very simple. The magnet is in a dry well, so all you do is shut down the system at this point, pull the magnet, open the bottom service port, and dump it into a bucket, and get rid of the debris and everything. Close it back up, put the magnet back in, start the system back up, let it bleed a little air, and you're off and going. I think water quality is one of those things that hydronic systems really needs to be looked a lot closer at, because I think we see a lot of premature failures on things just because of the fact our water isn't taken care of as well as it should be. I'm of that school that you fill your system up once and you watch it every 6 months after that. And the reason you're doing that is because you want everything to precipitate out that is bad. You want to do some testing on that water, check it for pH, check it for hardness, check it for the contaminants that come out of these systems, whether it be copper, whether it be flux and the other things, and treat it accordingly. I think that's key to good practice, and that's key to good longevity on a system. Just to talk a little bit more about how these hydraulic separators operate as decouplers. When my flow is equal, I'm a pass-through. It's a device that goes through and flows equally, on both sides of it. So again, it's not having to do any mixing. When my distribution is less than my boiler flow, it mixes back, a little bit of water back onto that boiler side, and still provides the adequate flow that the system needs. And vice versa. When the boiler has enough flow through it, but maybe the system has a higher demand, it will actually bypass to the system. And again, we pick up the same things with air elimination and debris as the system runs, and it helps. Again, it's a value added that you're putting into your system. I mean, again, we can all do closely spaced tees on these things and not get the magnetic separation or the debris separation, the air separation at a central point, without having to put in a lot of secondary devices. A lot of times the first thing out of everyone's mouth is, well, I can do closely spaced tees very cheaply, and so we had one of our guys go out and do a little bit of research, and we kind of took a rough swath at this. We looked at an 1.25" air separator, an 1.25" Y strainer for debris separation, a couple of 1.25" copper tees, and then we took some industry standard labor rates, the sweat connections. And so at $150 an hour, just kind of rough estimate, with 10 sweat connections, that came out to about $225. So, average 9 minutes per joint, cut, clean, prep, and sweat. It ends up being about a $459 install roughly. And again, this is just kind of a swath of it. If you're pressing, that might be different. The biggest difference you would see there is maybe, your fitting costs are going to be up about 15 to 20% different than what you would with sweat. So comparably, when we look at the base costs on an 1.25" air separator with fittings, and we're now dealing with 4 sweat joints instead of the 10, we're looking at a cost savings and time and labor and of about $410. So again, looking at this, I mean, people just based on how quickly they're able to make things happen in their field, how skilled their guys are, and that's really become one of the biggest issues in the trade, is getting skilled labor. Eliminating some of those fail points is key to having success and being profitable, I think, in a lot of these mechanical rooms. So, if you're looking for more information on any of these things that I've talked about today, we've revamped our website. It's www.resideo.com/pro/water. We've put a lot of the documentation that we had on multiple websites and consolidated into the single one now. And that's really helped to source some of this stuff and make it available to you guys out in the field, so that if you have questions and you need the PDF installation manuals, or you need, sales assistance with sales sheets or specifications or whatnot for fabrication, and they're available out there on this website and pretty accessible to you.
Well said, Mike. Before we jump into common questions, I'm going to jump in here real fast and say, as a reminder, if you do have any questions that came up on anything that Mike reviewed today, make sure to take a few moments, enter that information into that Q&A feature that's in your Zoom controls, and we will do our best to answer those questions in the time we have remaining. Thanks, Mike.
Thank you. So, to kind of help things along and maybe generate some thought on some questions, these are some common ones that have come up as we've talked about this particular part of our hydronics portfolio. How do I check the pressure in an expansion tank? We always look to do that off of the system. Walking up to a tank that's hanging and trying to check the pressure, you're never going to get a good reading. You need to isolate that tank, remove it, and then check your air pressure in it. Along those lines, how do I know if an expansion tank has failed? I mean, that's the good old knock test. You walk up to it and physically inspect it, look for the paint to have blemishes in it, maybe pock marks, maybe rust under the paint, maybe even a leak. If you see that type of thing, it's obvious that we've got some issues there, or we're about to. If I knock on that tank and it seems like it's solid all the way to the bottom, probably already have a bladder failure and it probably needs to be exchanged. So it's important, do some visual inspection. There's a lot of nice valves out there now for isolating these tanks, so that they're not the pain that we had to in the past, where you'd have to drain the whole system just to pull a tank. You can isolate it right there and hopefully get it taken care of quickly. How do I service the air eliminator? We've got a kit on both generations of our air eliminator that allows you to change out the float assembly if something should go wrong on it, or maybe a boiler sat dry and you get that buildup and crust in it or anything like that. And so it's a fully serviceable unit from that aspect of it. So, take advantage of that. What do I do if there's water coming out of the vent port on the backflow preventer? Again, that's what it's supposed to do. If we have a fouling problem or we have something stuck in one of those check valves, take the time, shut the water down, check that thing, make sure that we don't have some type of failure. There's not some kind of, rust shavings or, wood chips or something like that. If it's new construction, stuck in that device, and if need be, and you do find that it is a failure for some other reason, make sure you change it and make sure it's not leaking when you walk out of there. What is the service process for the hydraulic separator? We kind of touched on this. I mean, you isolate it from the fact that you shut the pumps down going to it. You basically drop a hose from the bottom of or put a bucket under it, open up that bottom valve and let it drain out. Close that valve, turn the pumps back on and let the system do what it needs to do to get the air that it's got in there out of it and move on from there. Does the magnet need to be replaced over time in the hydraulic separator? We're using a commercial industrial magnet. You'll hear people make the reference to rare earth magnets. This is not a rare earth magnet. This is an industrial magnet that has been chemically formulated basically, and it's a permanent magnet. And it's designed to be run in higher temperature. It's designed to be run, like I said earlier, in corrosive situations. So over time, I mean, if you find that it's not functioning, we'd like to know that most definitely. But more than likely, you'll never have to service or replace that magnet as long as it's in that well when you walk into the mechanical room. So.
Fabulous. Thank you so much, Mike. Thanks for walking through those common questions. We do not have any questions from our attendees today, which I'm going to take as a sign that you have answered any and all questions that anyone might have had during your presentation. So if anyone on the call does think of a question after the close of our training today, make sure to reach out to your local water Resideo sales rep or your Resideo sales rep, or you can even send an email to homes.university@resideo.com. We will make sure to get those questions answered if you think of something after the close of our training. But we will go ahead and close up a little bit early today. So Mike, if you want to advance to the next slide here. Yep. Training is something that we are very passionate about here at Resideo, and we want to make sure that you have access to several in-depth trainings that are available on our products inside of our learning management system, our LMS, or our online learning platform. We've got several in-depth technical and sales trainings available for all of our customers. You can access this online training catalog by visiting the training page on our Resideo Pro website. The first time you access that online training catalog, you are going to be asked to create an account, and then going forward, you will log into your training account to access these trainings. Currently, we've got about 20 online learning modules available. We've got many modules that go through our dehumidification portfolio. We've got a water training dedicated to our pressure reducing valves. We have modules on our T10 and Prestige IAQ thermostats. All of these online trainings cover anything from technical and installation details, and we also show you how to identify the right customer to sell these products to as well. We're very excited to add this training catalog to our suite of training offerings for all of our customers, and want to make sure that you are aware of how to access this information. If you are already a Resideo Pro Perks member, you will receive training credit when you enroll and take these online training courses as well. On the next slide, make sure that you pay attention to this website, as we are going to be updating our next few months of training webinars. If you search by either the plumbing or the HVAC tabs, you'll find details on our upcoming sessions. And then we always record these sessions as well, so you can find these recordings on this same website by filtering for webinars with the label on demand. And then one last reminder for our contractors who did not include your NATE ID on your registration form and you'd like to receive credit for attending today's live session, make sure to send an email with your first name, your last name, your NATE ID number, and the date of the session you attended to homes.university@resideo.com within 1 week of today's live webinar in order to receive credit for attending this live training session. And then 2 final things to note before we close out today. Once our training session ends, you are going to be prompted to complete a survey regarding today's hydronics overview session. Make sure to take a few moments to provide us with any feedback you have on this training. We are very interested in not only your feedback on today's session, but also we use that feedback to help us create future topics. So if you've got future session topics in mind, things that you have questions on the broader Resideo or Honeywell Home product platforms, we'd love to be able to create some training content for you there. So if you have suggestions or things you've got questions on, we'd love to hear that in that feedback survey. And then finally, you are going to receive an email from us in just a few days that includes some follow-up information on the products that we reviewed today, as well as a link to the website for more information on our trainings as well. Thank you all for joining us for today's Resideo webinar session. Have a great day, everyone.